Welcome back everyone, and in today's video we're going to explore a whole new topic. We're going to explore a character controller. We're going to experiment with how to read information from the keyboard and even from an Xbox controller by using the Gamepad API that exists within JavaScript and within Firefox and Chrome. I'm not sure about Internet Explorer Edge, but Firefox and Chrome should work just fine. Since we're getting pretty close to getting our armature animating in WebGL, let's start building up tools that we need to control the characters. So character controller. So we're going to use a cube for now to build up our character controller. So let's first look at some source code. So we're going to have our standard template, and we're going to have three objects that we're going to be building today, or going over. We have a character controller, a gamepad tracker, and a keyboard tracker. Those are going to be global objects, especially gamepad and keyboard, and I'll explain why they exist on a global scope. And on render, we're going to ask our gamepad to do an update, and we're going to ask our character controller to do an update. And I'll explain why keyboard doesn't need to be updated. So first, we're going to look at a character controller. So one of the main things you might want to think about is that like in this case, I'm designing the character controller as a class, and we can pass it in a target. So this way I can kind of control any object just by declaring it right here, and then passing in a renderable I want to control, which would be the cube. So ideally I should be able to put in an armature character and I'll be able to move it, but you'll probably need to extend this a little bit further to actually turn on and disable and switch out different animations on the thing. But like I said, this is kind of a bare bones, simple template to get started as a character controller. So we have a target. So that ideally, that's one of the things you want to do is maybe build something generic that you can just attach to some object to control. And you also want to control how fast your character can walk, and when you turn, how fast it turns when you press the left and right keys on your thing. So very simple. Have a debug function, and all it does is just create debug lines of where forward, left, and up is. That's all that I'm doing here. So this way I know I can see the direction, because direction is kind of important. Update, it calls the movement function, and if the character did move, it calls a debug, and that's it. And it just does the lines. So here's the first part of the movement function. So we have a variable called speed up, because I want to be able to press down a button and make the character start running instead of walking. So I'm using a speed up value that's going to act as a multiplier. And right now its multiplier is 1, so this way it doesn't change the speed, it doesn't slow it down or doesn't speed it up. And here I have something I'm calling for keyboard arrows. I'm trying to get the state of all the arrows that are currently for the keyboard. Do you have the up, down, or left, right, or whatever? Which buttons are currently active? So when the arrow is up, we're going to move, forward. If in a forward direction, if the mouse is down, we're going to move. Not the mouse. I'm sorry. If the down arrow is active, we're going to go in a negative direction. We're going to go backwards. It'll change the Z position of the character. Well, actually, not. It's not going to change the Z position. I'll get to that. And then when we want to rotate a direction that we're looking at, we use the left and right arrows. And we just, again, if you're going left, we're rotating 1 degree, or we're going to rotate in the positive direction. Else, we're going to rotate in the negative direction. And if the keyboard mouse or the keyboard space bar is pressed down, we're going to change the speed up value to 2.5. So we're going to go 2.5 times faster than we normally would. So if movement is enabled, so we are moving, we're not stopping, because we can rotate and not move, and we can move and not rotate. So I want to make it flexible so you can do either or do both at the same time. So if we are moving, like right now, if movement is not 0, then we are going to do some movement. We're going to take the target's forward direction, and the target forward direction gives us a vec3. that's a normalized value. But the way I built the forward function, I can actually pass in a multiplier. So this way, if I pass in the multiplier, it generates the normal direction that the character is currently facing, and then multiply that normal, and then give me the final vector, which I can then use as a velocity vector for movement. So that's really the gist of it. Instead of changing the z-axis, I just want to know where currently is my character looking, where is its forward position. And we've done this in the past where it's in the transform function. In case you forgot, it's been like months, if not a year, since we really touched the transform. There's the base class, and I tweaked it, I think, a little bit. I added some defaults instead of that's about it, you know. And I think I took out something in here that checked to see if D was undefined or whatever. But yeah, this is how, you know, if in case you don't remember or you're new to the series, we get the left, up, and forward direction through our transformation matrix. Once we compile our local matrix, these positions on the array is the actual not normalized, but it is a direction vector. So, you know, 0, 1, 2 is left, 4, 5, 6 is up, 8, 9, 10 is forward. It gives us the direction vector. And, you know, we just grab those values and then we normalize it. So this way we have a unit vector of that direction. So in case you forgot, there it is. It's in our transform function. Like I said, I added these a little bit into it, the defaults. So yeah, so once we know the forward vector, we multiply it by our scalar. So I have walk speed times move. So if we're going backward, it's going to be multiply by negative. So that means we're going to start moving backwards instead of forwards, and then we're going to multiply by speed up. So combining the three together, we get the speed, we get the direction, and we apply like a speed up modifier to it on top of that in case. Like if you're making a game and your character drops like a speed potion or something, character's going to speed up, you know. So you kind of have that kind of flexibility if you think about it. Or if your character you want it to run, like in this case, we hold down the space bar and we double the speed that the character is running. And now if you're correcting the left and right keyboard and you want to rotate your direction, because remember, we're going by forward direction, so when we rotate the character, its forward direction will change. And we're always going to just rotate by Y. And it's the same idea. We're going to use the turn speed times which direction we're going to rotate, and speed it up, yes or no. And that's it. And we just return true if there's any movement done during the update. And that's really just the gist of a simple character controller that just gives us the ability to walk, turn, and run. Excuse me. Now we're going to the actual controlling part. So we have the keyboard tracker, right? And if you've been doing JavaScript long enough, you know that you have the event listeners, key up, key down, or key press, right? So, but here's the problem with these event handlers. You can only get one event at a time. You can't tell if you have the forward and left button pressed at the exact same time. You can hold the button down, but then the events will get called over and over again. So it'll say move forward, move left, move forward, move left, move forward. It makes your character very janky. Like I did that first, and that was very, very janky. So what you really need to do is you need to create like a tracker. So when you do like a mouse event, it actually just saves a state to like an array. So I just save the key code and set it to true or false. Essentially, that's all I do. Well, here it is. On key down, I get the key code in the state. I set it to true. If I key up, that key code is then set to false. So every time I want to go and find out a key, I can call the key function, say, hey, give me the state of that key. If the key equals true, then it's on. If it's undefined or false, it's off. So that's how I kind of built it that way. So even if it's undefined, it'll just automatically mean off. It only turns true if it equals the value true. So, and then I have another function called arrows, which kind of just loops through and creates a nice structure, and it tells me these keys. And I have it like right here. It kind of just loops through this structure and then creates a new structure with these names, but with a true or false value instead. So this way I can call arrow once, and then I know all direction keys at the same time. It makes life easier, I guess. So I don't have to call key 4 times to find out each arrow. So in case you remember, like here it is. I'm just saying keyboard arrow. That's it. And then down here I do keyboard key just to check the space bar. and that's really just the gist of the keyboard tracker. It's something that lives globally, and it uses the browser event handling to just keep track of what buttons are currently being pressed. So this way, instead of like I said, you're bouncing back and forth between the events of left and each key that's being held down. You can just you update during every frame and just ask what's the current state. And it's and then in a lot of ways that's really how maybe like Unity works, because in Unity you don't have events for keyboard controls. You just request what's the current state of a key, and this is basically what maybe Unity is probably doing as well. It's just using keyboard events and just keeping track of the current state of the keyboard. And then the application itself just calls the tracker and say, hey, what's the current state? And that's why these live globally. So this way, your game can just call this global object and just see what the state is. The way I built this is it has to be instanced. This probably makes more sense to be built as a static class, which I should have probably done. At some point, maybe I'm just changing this to static. It just is this way you don't have to make an instance. Like keyboard tracker is just, that's it. You have to call keyboard. Maybe I'll just change it to just keyboard, or something else. But like ideally, maybe since it's gonna be global, might as well just make it a static class, so you don't have to instance it at all. The only thing maybe you might have to do is just turn it on, so this way the event handlers are set up, so this way they can start saving state. So that's really the keyboard tracker, and the gist of it. So now you can just move, and as you can see, when there's movement, the debug function gets called, and it shows me the left, the forward, and the up direction. And if I press spacebar, now you can see our character's like speeding around. I let go of the spacebar, it slows down again. This is the actual walking pace. There you go. Easy peasy, very simple. Now we're going to deal with the gamepad controller. Now, the gamepad controller tracker works differently because the gamepad API isn't like the keyboard. The gamepads don't have events. There's only 2 events, connected and disconnected. So this is kind of like the same type of controller object or tracker that we had to create for the Vive controller. The Vive controller doesn't have events either. You have to poll the data. And in case you don't understand what polling means, is basically you just ask repeatedly on an interval, hey, what's the state of everything? And that's what you have to do. So every time we run, every time we run our render, we do a gamepad update, which then calls the controller saying, hey, what are the states of everything? And then you kind of just save it. And that's really the gist of the gamepad thing. But there's a couple of things in here. So the way the gamepad API works is that you can do 2 different things. You can use the event handlers to find out when the controller is connected, or you can actually just poll for it the first time. So I opted just to do it this way. So you guys can at least, because I kind of like the idea of being able to know when a controller has been disconnected or disabled or whatever. So this way, like if an event happens, I can say, hey, controller has been disabled, it's not available, can you please turn it on? And then when the game, when it connects again, then you're like, oh, okay, then you can continue the game. In our case, we don't have to worry about it because we have a keyboard as well. So that's the first thing that that's the only thing you really have for the Gamepad Tracker. Let's see. Do I have update? Okay, so I just pressed the button on my keyboard. Again, now it knows the gamepad is connected, and here's an event. It gives you the index, it tells you the ID, and there's like other small bits of information. But if you output e.gamepad, you'll get tons of other bits of information. But the only thing that really matters to us is the index and the ID. Because index is just, you can actually have more than one gamepad connected to your computer. So this way you can actually track multiple gamepads. What I built is just a single gamepad thing. It doesn't track multiples. So this is like a bare bones, simple, like I said, get started type of object. So yeah, and and all I do is check to see if it's an X input. And in case you don't know what an X input is, that is what Microsoft calls the input for its Xbox controllers. So I have an Xbox One controller that works for the PC. You can also use Xbox 360 controllers they have for the PC, or do you have to buy like the wireless adapter? I have that for my downstairs PC, which is an Xbox 360 controller. Upstairs, I have an Xbox One controller for my development box. So that's what X input is. So that's why I'm checking to see is this in like an Xbox input. And I think a lot of inputs or gamepads you get probably is going to be X input supported. So that's what you end up seeing. But you can, like I said, on Connect, I output the information. So you get to see all the controllers that are currently active on your computer. So when it connects, I check to see if it isn't an Xbox controller, and then I check to see if the index has been saved. So right now, by default, there's no index. So I know I have not found a controller yet. So on Connect, first Xbox controller that's found, that's the one I'm going to use. So I save the index, and then I call a function called Xbox Profile that I built. I'll show you that in a second. And then just say it's ready. We're all ready. The index is set up. We're good to go. We're ready to go. And the function I have here, it just sets up the configuration. Like I sit here and just actually sat there and just listened to all the buttons that got pressed. That's not really listening. I had to sit there and just output all the information and have to press it. I could have looked this up, but I decided to kind of just do it the hard way. So basically, I set up a profile, like in a way to, so this way, like if you have different controllers that maybe are not an X input, maybe there's something else. I don't know. They get treated differently. So this way, you can kind of set up how to pull the information out. Like to get the joysticks, there's something called an access. The access. Let's see. Let me open up the update. So maybe I should go talk about this one first. So the Xbox profile is basically what is what. So if I want to get the left stick, it's the X0. Oh, this is just the value. Wait, why is that? It's the index 01. Oh yeah, that's just the value. So these struct values are what's going to be stored, and that's what I'm going to use. This is what I consider information that's kind of important. So to get the joysticks, you have to check the gamepad's access. There's an object called access. Like I said, I don't know how to explain this. I probably should explain the update first. Okay, so every time we loop, we're gonna have to get the information first, right? So we're gonna say navigator, give me the gamepads, and you have as an array, give me index, like say 0. So I get all the information, all the current states of every single button and every access, everything else that's for the gamepad. So I save it to GP. So GP has an array called buttons, and has another array called axis. So the buttons is just a huge array, and it has their own struct, and it has I think 4 bits of information, and I have it saved up here. It has pressed, has a value, and has touched. Pressed is true or false. Touched, I think, just turns true or false, really. And value is usually between 0 and 1, unless it's the right sticks or the trigger buttons. If it's the trigger buttons or the sticks, that value is always going to be between a value between 0 and 1. I'll explain why in a bit. So, like I said, so we have buttons, and I'm only going to check this for a value. And I'm going to check for values larger than dead zone. Because when we're dealing with axes and the trigger buttons, they don't always go back to 0. There's always like 0.01, 0.02. There's like this little, like I said, it never becomes perfectly centered, or never becomes completely unpressed. So I needed to set up like a dead zone. So any values greater than 0.1, I consider to be turned on. So you have to press the joystick just a little bit for me to register, and you won't notice it because you're not gonna time like a little centimeter worth of movement on either button, or 2 or 3 centimeters, or not centimeters, like millimeters, like really small movements, just enough to register that you kind of are moving the joystick. Like I experimented. 0.1 worked pretty well, where there was no false like movement. Because the key, my gamepad is not perfect. It's not perfectly calibrated, I guess, or no gamepad ever is. I messed with gamepads in the past before, and they're not always perfect. No gamepad's perfect. So you kind of always have to have it set up kind of a dead zone value to register your controls. But when it comes to buttons, the value is only between 0 and 1, so it's kind of a waste of time to do this. But like I said, the trigger buttons are part of the button list. So I just loop everything the same way instead of treating those 2 values as something separate. Because ideally, I just have to check to see the value. I don't even have to check anything, to be honest. I probably should, for most buttons, just use press. Excuse me. Because that's a true or false value anyway. But like I said, I didn't want to treat it any differently. Like probably if I was going to do this for real, like for efficiency, I probably would treat triggers separately from the rest of the buttons. So this way I can not do the if statement. But like I said, I want to make this as simple as possible, less lines of code. Just treat all buttons as if they're all triggers. There will be no difference. Like I said, I'm checking for 1 and 0, or I'm checking to see if there's any value greater than dead zone. So if the value is greater than dead zone, then you're turned on. So that means you're greater than 0. If you're less than the dead zone, that means you're off. And also check if it has changed from the previous state. So like I'm saving it here, like it has changed. Like state tells you what state it is, and has changed is, in this current frame that I'm rendering, this is the first time that the state changed. So if I press down a button, I say, okay, this is the first time that you actually press down the button. This is the first frame that I register that button. The reason why I want to know if the button's just been pressed instead of just knowing if the button is pressed is like maybe if I want to be able to control something, or like I want to turn something on, turn something off. So I can just say, button A has changed. If it hasn't changed, I'm not going to do anything. If the value says has changed, then I check the state. Is it on or off? And then I just do what I want to trigger. So that's the reason why I'm checking the state. So it's very easy. I'm just checking the value and checking the state that exists from the last frame, and I update that value. Then I actually update the state value. So if I were to have this backwards, like state here, then has change will always be false. So it's an order of operations things, but it makes things very simple to code if you put things in the right order. So, and that's really how buttons work. And then you have joysticks, and the joysticks are much more simpler. There's no like structure, an array of structure. It's really just one array, and depending on how many joysticks you have, you'll either have 2 or 4. So if you have 4, that means you have 2 joysticks. If the length of this array is 2, that means you only have 1 joystick. It's X, Y, X, Y. So that's why I kind of saved the index, X index, Y index in here. So I know which element in this array is the left stick and which one's the right stick. And this is the same reason why I have the buttons. I save all the indexes since the buttons is just an array of structures, and this is the structure that makes an array of. So when I loop through my buttons, I use these values to find it and then save the information. And that's why I call it profiles, because maybe you might have another like let's say if you get the PlayStation 3 or PlayStation 4 keyboard, they're going to have different buttons. Their indexes might be slightly different. So, but then you have to check the profile. You have to check the ID of the controller that you're loading in, and then I guess create a PS3 profile. So this way you can then very easily have something set up. So this is when you request an update, because I save the values here. Like I don't have to request anything. I just go to Gamepad buttons and then check A. Is it on or off? So we'll see that code in a bit. The only issue with the Gamepad is I have to flip the values. Like here's a negative here. I need to flip the Y and X because OpenGL works differently. Forward is, even though I have everything set up as a positive, the camera is always facing in the negative direction. So I always got to go negative when I'm dealing with Y, which basically is because that's just how the camera is. If I were to change a couple things, I probably can use positive for Y. But X, I can't do anything much about. I have to flip it because the positive direction is left. It's not right. So I have to flip the values so the Gamepad passes in the right information for me to use in WebGL. So that's the only thing you have to keep in mind, because I was pressing left and I was going right. So once I start putting flipping the values, I start going in the direction I want to go in. Yeah, so that's the only thing you keep in mind. I flip the values. And like I said, I do an absolute value because these axes values create a value between -1 and 1. So if you're going all the way into negatives, you're going one direction. If you're going to positive, you're going a different direction. So to test it for dead zone, I need to make an absolute value of it first, because I don't want to deal with negatives, just with positive. If it's greater than that dead zone, then save the information and save its current position, and then I check to see if it's not 0. And if either one of them is not 0, that means that joystick is active. So I'm tracking if you're currently moving at all with the joystick. I'm not saving it has changed, but I can if I need to. If I need to do it that way. And that's really the Gamepad API. There's not really much to it. It's just, like I said, you can poll it. Like I said, you can just do this, and it gives you an array, and then you can just check to see which ones exist, or you can use the event handlers. But like I said, I use the event handlers, and then I do the polling right here. And the only important things is buttons and axis, and that's it. And like I said, they're just arrays. Like just output or console.log, and you'll see stuff like this. And now we just look at the character controller. So I had the keyboard controls, and now I have here. So with this one, I say gamepad joysticks, because I think I have a function called joysticks, right? I forget now. Let me look. What's joysticks? Oh, no, it's just the object. I'm sorry. So it's joysticks. And then I'm using the profile because I know I want the left stick. So joysticks, left stick. Oh, that's right. I'm also using map. That's something kind of new in JavaScript. I have a link here for it. It's a dictionary. I haven't used it before, so it's kind of like an alternative for using this. But it's different. Like a map function allows you to use an iterator, so you can loop through it like this. Like do item of. It's different from something in, like for in. This is for of. So for this for statement and these map is new to I think ES6 or ES7. I forget. I think it's ES6. ES6. So yeah, I'm trying them out to see how I like them. They're a little different, but they're dictionaries. So you kind of have a key, and then this is your value. So the key value pair objects. So that's what for the profiles. That's what I'm using. I'm using a map function and setting up key value pairs. Then I just loop through the keys. But that's what the values are. No, I'm sorry. I'm not looping through the keys. I'm looping through the values in these loop statements. So I'm basically just looping through these structs that I'm creating, or these objects I'm creating. So yeah, so once I have this, since joystick is a map function, that's why I'm using get. So here's gamepad, here's that map object, and I'm saying give me left stick. So I get the left stick information. I check to see if it's active. If it's active, that means you're pressing it at least. Then I start using it. So if X, like I say, I don't have to modify the data. Data's already set up perfectly for me. That's why I flipped everything. So this way it works perfectly without me actually have to modify it in my character controller. And then I check to see if the A button. So I ask it, is the A button? So like I said, it's right here. Here's the buttons. Here's the key. I'm asking for that key. And then I get back this object that I update. And if that state is true, I do the speed. So if I hold down the A button, I run. And that's the controls. So if I come back here, refresh, now we use my controller, and there we go. Press forward, and I go. Press A, and I could run. Turn around. It's hard to control it when it's like going in the opposite direction. Now, the idea in reality, the character controller that you might make for a game, especially if you're doing like a first person or even a third person, you might base movement on the direction of the camera. See, I'm using the direction of the character itself to know how to move forward and how to turn. Really, mostly just how to move forward. So it's a little funky to control it because, like, I have to press forward to make it come toward the screen, but it makes more sense to press back on the keyboard on the joystick to make it go back. But if I were basing it on the camera direction, then it would make perfectly sense because then you move it based on how you perceive the world, like I said, based on camera movement. So you can do that if you want. You, instead of using the character forward direction, request Fungi's main camera and get that forward direction, and that way you can then very easily control your character. Using the camera instead of the character's direction. So, one other tidbit when dealing with character controllers and controls in general, as you can see, I'm checking the keyboard and I'm checking the gamepad. Ideally, what you want to do, especially if you want your users to be able to remap their keys, especially when you're dealing with PCs, you have so many different type of controllers. It's kind of important to be able to remap your keys. So what you want to do, like if you're going to really build a game, you want to build maybe a super controller like tracker, something that allows you to set up actions and then define what buttons perform those actions. So let's say I want to perform the run function, a run action. And then I say the A button on gamepads and the space bar on keyboards. That performs the run action. And then in my character controller, I don't have to call for the keyboard or I have to check the gamepad. I just check to see, can I perform the run action? And that object will then check the keyboard and the gamepad for you and say, well, okay, the space bar is turned on, you can run. Or the A button is turned on, you can run. So you can kind of get rid of all this garbage and then build a kind of much, I don't want to say simpler. It's simpler, let's say, as an end user for yourself, as a developer. But if you're building tools, it makes it, I guess, more complicated because, like I said, then you have to build a system that allows you to kind of create actions and define which keyboard keys and which gamepad buttons allow you to do that action. So I'm not diving that. If you really want to do that, go ahead. That's a challenge for you guys. Like I said, it's not too hard, but you kind of have to sit down and think about it. Like, how do I do this? You have to, like I said, you might have to set up two different. I don't know. If you sit down, I'm sure it's not that hard, but like to me, like, how would I do it? Okay, so I don't know. I probably would do like a text file, like especially if I'm doing a desktop game. So this way the user can then change the keyboard keys. So that's kind of another thing you have to keep in mind. Is it something going to be static, or do you want the user to be able to remap? So if the user is going to remap, then that object needs to be a little bit different. It has to be a little bit more flexible. So instead of just me hard coding it, then you kind of have to. Well, you need to make a text file that can be modified or some way to store and change information. So this way you can kind of let the user modify and then take it. Because like I said, if maybe the user doesn't want to use spacebar to run, maybe they want to use the Alt button. In the end, that type of controller system won't matter because all I'm asking to see, can I run? And that object that checks the keyboard and the gamepad will just do what it's been configured to check for and tell you if you can or can't. So that's more of an advanced character controller or a more advanced controller tracker or something. So yeah, just some way to, just, I don't know. And I don't want to go into it too deep and waste too much of your guys' time. So yeah, that's a character controller. We got a cube. I can't wait till we can get Bendy in here and have him control him running around. At some point I might do maybe a following camera. So this way we can do like a third-person type of movement in our 3D space. So we're not just stuck in one place. So we just follow the character, and maybe we can use the second joystick to control the camera, like the orbiting, things like that. So that might be down the line in future videos. So hope you enjoyed it. This probably went longer than it should have for, I think, such a simple topic. Like I said, there's not too much to the code. Like I said, you can do more. You can make it more complicated or more complex. But in the end, it will be more beneficial for you to do it that way. If it's more of an action-based as opposed to just dealing keyboards and gamepads. But the whole point of this video is really to illustrate that to check keyboards, you kind of have to save state. And then just have these events kind of save it for you in some type of array or dictionary, whatever object you want to use that makes sense, that you feel is more efficient for how you want to code it. And same thing with the gamepad. The gamepad, there's no event driven. You have to go out and do it yourself. You have to go do an update yourself to grab the state. Like I said, your super controller, probably do an update. It will actually do the gamepad update for you, and then it will then compare what the keyboard has compared to what the gamepad has, and then they'll update your list of actions if you can perform them or not, yes or no, for this current frame. That's how you probably would build your super object. Um, if it's a big deal, like if let's say 10 people comment saying they really want a supercontroller, I'll make a video and I'll write the source code for you guys. If you can't come up with it yourselves, I will do it for you. No big deal, and show you how I would implement something like that. Maybe even with the ability to have user if definitions, maybe maybe it shouldn't be too hard. But like again, if really people, I don't want to waste my time doing it if no one really cares. Like I don't even know if anyone's gonna care about this video about controlling a cube. But like I said, this is gonna be important when we can get Bendy in there and start having things to play with. Like gonna have collisions at some point soon. We need to be able to move objects to do collisions, so we can have maybe fit. I want to do like a basic physics engine, so we can climb and walk and run, fly, jump. There's tons of things I want to do, but we got to get there. We need a character controller. So that's kind of like the first step. You need to be able to control your character before you can perform any actions that you want the character to do. So yeah, it's getting hard to. So yeah, I'll end it like here. Next video is gonna be a fun one. I'm actually gonna record it right after this. Yes. Oh, maybe. I don't know if I have time. I'm gonna try it too. Okay, so the next one's gonna be a fun one. I'll see you guys soon.